Hey everyone, let's take a look at number 2 in section 4.4. I've got it pulled up on the screen here. We're given the graph of the derivative f prime of a function f from on the interval from -4 to 4. And we're going to restrict our answers to this interval from -4 to 4 along the x-axis. And the first question is to determine the intervals on which the function f is increasing. Okay, so where's f increasing? Well, what you're not going to say is that f is increasing from x equal -4 up to x equal -3, where this graph is increasing here. Why are you not going to say that? Because this is not the graph of the function f. This is the graph of f prime. Okay, how are you going to answer the question, where is f increasing? You are going to, you don't have the graph of f, so how do you do this? You need to know the fact that when a function is increasing, its derivative is positive on that interval. So any interval where the derivative is positive, the function f will be increasing. So where is the derivative positive? When the graph is above the x-axis. That occurs from -4 to -2, right? On that interval, the graph is above. Do not include -4 and -2 because it is 0 at those points, right? So let's just everything in between. Also between 2 and 4, right? The graph of the derivative f prime is above the x-axis. So in here, I'm going to use parentheses, interval notation from x equal -4 comma to x equal -2. Close. Actually, I'm going to go ahead and use that. I don't think it really matters, but just to be careful here, -4 comma -2. Close that. So I'm using this template down here. And then we're to use the union symbol. This is the union symbol for combining intervals. So I'm going to use that union symbol right there, and then open parentheses from 2 to 4. And close parentheses. So there hopefully is my first correct answer. Determine the intervals where the function f is decreasing. Okay, well, that's going to be where the derivative is negative. So we're looking now at the graph of the derivative. When is it negative? When it's below the x-axis. So this portion here between -2 and +2. So that's where the function f will be decreasing. So -2, comma 2, close parentheses. Okay. 2 more questions. Determine the intervals on which the function f now is concave down. Okay, where is it concave down? Do you remember what concave down is? Well, are we going to say it's concave down on the interval from -4 to -2 because the graph looks to me to be concave down here? No, we're not going to answer it that way because this is not the graph of f. This is the graph of f prime. We don't have the graph of f. So how are we going to answer this? Well, you need to know the relationship. A function is concave down on an interval if the derivative is decreasing, right? If the derivative is decreasing, that's the definition. It's also true on that interval, if the derivative is decreasing, that the second derivative is negative, okay? We don't have the second derivative though, we have the first derivative. So I'm looking for where the first derivative is decreasing. Where are we going down, right? Well, at -3 about, we have a local max and we go down to the local min at x equals 0. So from -3 to 0, we are decreasing. So let's first do that one, -3 comma 0. But then we have another one here, right? We're also decreasing here from about x equal 3 to x equal 4. So from 3 to 4. And notice again, I'm using parentheses. I would encourage you to use parentheses or open interval here. We don't need to include endpoints here at all. Okay, because we're looking on the interval between what two values is the function increasing, decreasing, concave down, and now the last one, concave up. Where is it concave up? It's concave up where the derivative is increasing. So where is the graph of this function, the derivative increasing from -4 to -3, and then again from x equals 0, it's going up, up, up till we get to x equal 3. So from -4 to -3, union, and what did I say, from 0 to 3? Yes, from 0 to 3. Okay, let's check our answer and see what we get there. All right, we solved it in one attempt. Yay. Okay. So hopefully this helps with that. And if you have questions, as always, please let me know.